Hi guys, page 4 of the geometry pack is all about finding the area of shapes and starts with really simple rectangles. Okay, so first off, what does it mean to find the area of something? Well, it means find out how much 2D space is inside the shape. Okay, but how do we do that when we're just given lengths? Well, if we offered up a ruler to this edge, how far would we move down before taking another measurement? We can't really use a ruler to measure area because a ruler measures something which is one-dimensional, just a line. To measure a 2D shape, we need a 2D unit of area, so we use squares. So if we split this shape up into squares, so these are 1 centimeter squares, each one of those is 1 square centimeter, and we should say it like that rather than 1 centimeter squared, because that can lead to some difficulties later on if we keep saying centimeter squared. So how many square centimeters have we got inside that shape? Well, we've got 5 rows of 3, or 3 rows of 5. So altogether we have 15 square centimeters. So the shortcut for finding the area of a rectangle is just to times the length by the width, or the height by the width, however you want to say it. So just times the numbers together, that gives us 15. And one way to remember that the units are square centimeters is that if we times centimeters by centimeters, it becomes centimeters squared. Okay, but as I said, try to say it as square centimeters. Okay, so for this first question, we're just going to times the width by the height, so the area is 9 times 5, so 45 square centimeters. Just watch out for units on these. Other than that, they should be quite straightforward. I'm going to pause the video here, have a go, and then have a look at the answers. Okay, here's the answers to those questions. Just note that this one, part C, was in square millimeters, and the only other thing I want to mention is that for question D, it was a square, so just doing 15 times 15, but we could also write that as 15 squared. This is where the term squared comes from, because it would give you the area of the square with sides of 15, and that's equal to 225 square centimeters. Okay, on to question 2. Work out the area of each of these rectangles. So question is the same. However, what's different about this question is that the units differ, so just look out for that. You're going to need to convert these into the same units. It doesn't matter whether you convert them both to centimeters or both to meters, as long as you are explicit in what your units for your answer are. So for this first one, let's say we did it in centimeters. This top length can stay the same. This one would be 100 centimeters. So 90 times 100, adding on 2 zeros to 90 would give us 9,000 square centimeters. Or if you did it in meters, it's this one we would need to change to 0.9 meters. And if we did 0.9 times 1, we would get 0.9 square meters. So you just need to be explicit in whatever units you're giving in your answer. Okay, have a go at the others yourself, and then pause it here and I'll show you the answers in a second. Okay, there's the answers to parts B and C. Let's have a look at number 3. On this question, they've given us the area of the rectangles but removed one of the lengths, so this is doing it in reverse. You can choose to write it out as you would do ordinarily forwards, if you like, first. So for example, 3 times something equals 24, and I'm not going to put the units in there. So how would we work out this missing number here? Well, the inverse operation of multiplying is dividing, so we would do 24 divided by 3, and that would give us 8. So if two things multiply together to give an answer, you can divide that answer by one of the things to get the other thing. And this would be 8 centimeters, because it is just length at the end of the day. It's the area which is measured in square centimeters, so this is just 8 centimeters. Okay, again, pause the video, have a go at B and C yourselves, and we'll go through in a minute. Okay, there's the answers to question B and C. Let's have a look at number 4. So it says these two rectangles have the same area, find the length of the second rectangle. So first we're going to find the area of the first rectangle by doing 8 times 5, and that will give us 40. So 40 square centimetres is the area of that. It's also the area of this rectangle, and it therefore becomes a question just like the ones above. 2 lots of something equals 40, so 40 divided by 2 would give us 20. Okay, question 5. A rectangle has an area of 80 square centimetres and a perimeter of 48. Find the length and the width of the rectangle. So we're looking for two numbers that times together to give 80 and add together to give half of 48. Okay, and the reason they only add together to give half of that is because if this is a rectangle, those two edges would account for half of the overall perimeter, and the other two edges, I'm not going to join them up specifically so that you can see this, would form the other half of the perimeter of the rectangle. So when they add together they will equal 24 and we just have to think about things that would work for that. So if we write down the factors of 80, so 1 and 80, 2 and 40, I've not got anything that will add together to make 24 there yet. 3 doesn't go into it, 4 does, 4 times 20, there we go, look, 4 times 20 is 80 and 4 plus 20 is 24. So our length and our width are 20 and 4 respectively. And it doesn't matter which way round they go either. Okay, and the last one on the page, Mr. Wood is tiling his bathroom floor. The bathroom floor is a rectangle measuring 4 meters by 2 meters, and each tile is 20 centimeters by 20 centimeters. How many tiles does he need? There's two ways to do this question. Method 1, I guess we could call it. You find the area of the bathroom floor altogether, and you find the area of each tile, and you divide the area of the bathroom floor by the area of each tile. Okay, so I'll just show you that method. So because the tiles are in centimeters, I'm going to work out their area first. So that will be 20 times 20, or 20 squared. So they have an area of 400 square centimeters each, which seems quite large, but a square centimetre is quite a small thing. And the bathroom floor, let's call it the floor area. Now this is going to be a very big number. So we've got 4 meters, and remember I'm doing this in centimeters, so I need to change that into 400, and it's by 2 meters, so I'm going to change that into 200 centimeters. 4 times 2 is 8, and then I've got 8 zeros there in that, sorry, 4 zeros. So that is an area of 80,000 square centimeters, and then I'm going to divide 80,000 by 400 to see how many tiles I need. Okay, so I can cancel off a couple of zeros there that are common to both numerator and denominator in that division. So it's the same as doing 800 divided by 4, and that gives me 200. So I need 200 tiles. So that's the first way to do it. There is, in my opinion, an easier way to do it. So method 2, and here's how it goes. It kind of removes the units from the calculation and just deals with tiles as if they were a unit of area themselves. So what we need to do is work out how many lots of 20 centimeters would fit into 2 meters. In other words, how many rows of tiles would we be able to lay along this wall here? So how many lots of 20 centimeters go into 2 meters? Well, that would be 10. So we'd be able to fit in 10 rows of tiles vertically in this diagram. And how many lots of 20 centimeters go into 4 meters? That would be 20. Quite often on these questions the numbers are easier than this to see, but still a good example. So we have 20 columns of 10 rows, or 10 rows of 20, and that would be 200 tiles. This method can often be quicker, I think, to get to the answer.